So before I pass out for tonight, I just want to quickly record what do you have to do for homework 2 question 3. All right. So let me make this full screen. All right. Let's look at what the question 3 asks. All right. So now you got to use XFoil for this analysis, right? And I have the tutorial on slide. Using XFoil, you get what is called coefficient of pressure. We're going to talk about coefficient of pressure in detail in the next class on Monday, but we kind of introduced what coefficient of pressure is, right? So basically what you're going to do is you're going to find the coefficient of pressure distribution on the upper and lower surface of NACA 0012 at 0, 4, and 10 degrees angle of attack, right? And now you will get different plots for these different angles of attack, and I want you to put in the same graph so that you can compare and contrast easily, all right? So you gotta do that, and it's not just enough to generate the graphs, but you also have to describe the changes that you see in the coefficient of pressure, right? And basically trying to read the graphs. In most engineering classes, you just get an answer and move on, plot the graph, move on. We're not gonna do that, right? We are going to look at the graphs and see what is different, what is same, some kind of analysis that goes into the to calculating the CP and all that. So, right, and also there's a relation between CP and velocity that occurs over the surface. So we're going to talk about that as well in class. And after we talk about that in class on Monday, if we have time, just go back and fill in that detail in the homework, and you can turn it in by Monday, right? And also, this is an important aspect that any concept you hear in class, you always have to relate it back to your wing case. Just think about how the coefficient of pressure will change for your research case at the different angles of attack. So now you don't have to think about these angles of attack. Just think about any angle of attack cases, any velocity, any conditions. You have to see what the coefficient of pressure, will be for your case. So there's, we'll talk more about the significance of the coefficient of pressure on Monday, right? But these are the things that you need to do for the question 3, okay? So on this slide, I have actually documented the steps you need to follow to get this running, okay? Now, I'm going to show you this step by step. First things first, you need to download the XFoil from this website. I believe there is a in XFoil file for Mac as well and Windows. So I'm running Mac and Windows side by side for various purposes that I don't want to get in this time of the night. Alright guys, so I'm going to open, so I already downloaded this XFoil, right? I'm going to open my XFoil and you will see this command prompt window pop up, right? So again, when you download, it'll be in a zip folder, just unzip it, right? The neat thing about this is all the NACA series airfoils are actually embedded in the code. So all I have to do here is type NACA 0012 and it shows me all the parameters. I hope you guys can see. When you do this, when you see this video, just make sure to watch in HD, right? So that you can see all these numbers. If you want, you can zoom in, right? So once you type the airfoil name, click operate, Opera is kind of in doing the operation. You can actually see the command change from XFoil to Opera I. So I stands for invisib. Okay. Now you can actually change it to viscous by doing VISC, press enter, and ask you for a Reynolds number. So we're gonna test all our cases at the Reynolds number of around 60,000 or around 100,000. So that corresponds to about 30 meters per second. So I'm just going to write 100,000 here, but you're going to have to calculate the actual Reynolds number that's involved, okay? So this 100,000 Reynolds number, and then press enter, right? And also you have to set the angle of attack. So I'm just going to do alpha 2 degrees, and you got to do 0, 4, and 10. I mean, you can play around with that. So minimum you have to do 2, but you can, if you're feeling curious, then you can just do multiple angles of attack as well. So alpha 2, press enter. There you go. Just press enter and you will actually generate you the CP plot. So here is you have a CP plot, but note the axes are reversed. The positive is on the lower side of the y-axis and the negatives on the upper side. Again, this means something. We're going to talk about that in class. All right. So that's all there is to it. Again, you can go back. So if you want, so this is the CP plot, right? Don't, I prefer you download this data and plot it in Excel. Okay. Now you have two lines here. Dotted lines represent inviscid solution, and the dark lines represent a viscous solution. In inviscid solution, of course, you don't have a boundary layer, right? So this is what you get for an inviscid, and this is what you get for viscous flow, right? So that's the difference. Again, I have, I'll iterate. The dotted lines stand for inviscid case. So that's what you get when you run an inviscid solution where you ignore its viscosity. Now, when you take viscosity into account, this is what you get, right? The dark lines, right? All right. So the way you can take the data out is, here's the command, do cpwr, right? And then do file name, I don't know. So it's like midnight go to sleep. I'm just gonna name it, all right? txt. There you go. So when you go into the folder where you actually have the X file, you will see all the data. So copy and paste this in Excel, and then you can plot. Okay. All right, guys. And oh, there's also another tutorial I posted online, so you can watch it. Right, if you have any more questions or doubts. All right, but it's very simple. Okay. All right, guys. We'll see you Monday.